Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So, today we will be going through some of the exam style questions which are related to chapter number 2. So, let's get started. Question number 1 is: a top sprinter in the 100-meter race will accelerate at a rate of 5.5 meters per second square in the first 2 seconds of the race. Okay, so the distance is 100 meters and acceleration is 5.5 and the time is 2 seconds. Okay, find how far the sprinter runs while accelerating. Okay, so in this question, we need to find out that how far the sprinter runs while accelerating. Okay, because the total distance is 100 meters, we need to know that in the first 2 seconds how much distance was covered. Okay, if I just draw a quick diagram just to represent the exact situation, so I can say that this is, let's say, point A, which is your starting point, and this is point B, which is the ending point. Okay, the distance of the whole track is 100 meters. Acceleration is 5.5 meters per second square, and let's say just that about over here, okay, t is equal to 2 seconds. All right, so now whenever you need to solve equations which are about constant acceleration, always use the SUVAT form. Okay, so here we need to find out what s is, that is what's required. U is equal to 0. Okay, the initial velocity will be 0. We are not interested in that. A is 5.5 meters per second square and t is equal to 2 seconds. So we know u, we know a, we know what is t, and we need to find s. So the equation that links all of these four variables is s is equal to ut plus half at squared. Okay, so make sure that you are familiar that, okay, that in which situation you should use which equation. Okay, so you need to see that what variables are given to you and what variable you are required to find out and what variable is not needed. So in this case we don't need v, so therefore in this equation there is no v. Okay, all right, so now we'll just plug in the values. U is 0, so therefore this whole term becomes 0. Half times a, which is 5.5, and t is 2, so square of 2, and therefore 2 and 2 they will cancel out, so we'll have 2 and times 5.5, so 5.5 times 2, that'll be 11 meters. Okay, that is part A. Let's move to part B now. Assuming that the sprinter runs the rest of the race at the speed he attained after 2 seconds, find the total time he takes to run the race. Okay, so there are two things, if you notice. It says assuming that the sprinter runs the rest of the race at the speed he attained after 2 seconds. So whatever velocity he had after 2 seconds, okay, that velocity was maintained till the end of the race. So that means this is constant velocity, and between this region, the acceleration will be 0. Okay, all right, what else it says? It says find the total time he takes to run the race. All right. So basically, first of all, we need to find out what is the velocity that he attained after 2 seconds. So now we can find out that, okay, again, if we use the SUVAT equations, in the first 2 seconds, the distance that was covered was 11 meters. Initial velocity was 0. V is what we need to find. A is 5.5 meters per second squared, and t was 2 seconds. Now over here we have four variables given to us. We need to find the fifth value, right? So we can use multiple equations, but what I'm going to prefer is, this is my personal preference, and it is recommended that do not take this value. Why? Because this is the value that you have calculated in part A. What if this value is incorrect? let's just say that this value is if this value was incorrect, then your subsequent calculation will also become incorrect. Okay, so if there is an option that in which you can only use the values which are already given in the question. So let's say that I ignore the value of s. I have u, I have a, I have t, and I just need to find v. So I can quite easily use this equation, v equals to u plus at. And that is the safest option. Even though if let's say that my part A was incorrect, that would not impact what I'm going to get over here. So do you get my point? So that's why this is a much better approach and a safer approach. So u is 0, a is 5.5 times 2. So the speed is 11 meters per second. So what is this speed? Speed attained after 2 seconds equals 11 meters per second. All right. Now, so once we have found this, now we need to find that, okay, what is the total distance, sorry, that how much total time it takes to cover, to complete the race. Okay, so that means now from t equals to 2 seconds to t seconds, okay, because we don't know that how much time this is, the displacement is going to be 100 is the total distance of the racetrack minus 11 meters that which were already covered in the first 2 seconds. So that will be 89 meters. So basically what we are trying to work out is that after 2 seconds, how much more time does it take between this region? So the distance over here will be 89 meters because 11 meters were already covered over here. So I hope that this is clear. Okay. Now the initial velocity will be what we found in the first part of this answer, which is 11 meters per second. So that will be my initial velocity. Okay. Then we don't actually need that, and that would not help us because the velocity is actually constant, right? So v will also be 11. So acceleration, now because this is constant velocity, so acceleration is 0. And then t is what we need to find, that is t seconds. So again we have s u a t, so we can use the equation s is equal to ut plus half at squared. All right, now this is 89. Okay, and initial velocity is 11 and t is the capital T plus half times acceleration is 0, so this entire term becomes 0. So we will be left with 89 equals 11t. T is equal to 89 divided by 11. Okay, all right. If I read the question one more time, it says find the total time he takes. Okay, so do not forget that if first it took 2 seconds and then it took this much time, which is 89 upon 11. So total time equals 2 plus 89 upon 11, and that would give us 2 plus 89 over 11. So our answer will be 10.1 seconds to 3SF. All right. Remember, if your answer is non-exact, then round it off to 3SF. Okay. So that is the end of question number 1. Let's move to question number 2 now. All right. A ball is thrown vertically upwards at a speed of 45 meters per second. Okay. Find the maximum height reached by the ball above the point of release. Okay. So let's say, as I mentioned, that it is a good idea to draw a diagram so that it becomes visually clear what's going on. So let's say that this is your ground level. Now we don't know at this moment whether the ball was released from the ground or from somewhere above the ground. So I'm just going to assume that this is your ground. and let's just say that this is the point of release. Okay, so this is the ball. Now when the ball is thrown upwards, okay, the ball is going to go up all the way, is going to reach the maximum height, and then it's going to come down. Okay, so this is point O. The ball goes up and then it comes back down at this particular point. Okay, let's say that this is where the ball reaches its maximum height, so this is S max, and S max will be the displacement from the point of projection, from point O. Okay, all right, so we know that the initial velocity was 45 meters per second. Okay, and this is a question which is about vertical motion. All right, so let's write down the data that is given to us. First of all, I'm going to take upwards as my positive direction. Okay, now S is equal to S max that we need to find. Okay, because that's what the question is, right? Maximum height. U is 45 meters per second. V, now understand something, and it is very easy to visually to visualize it. When you throw a ball upwards, okay, and when it goes to its maximum height, it comes to rest for a moment, isn't it? Before it comes back down, it goes up, it stops for a moment, and then it comes down. So because it stops at that moment when it reaches the maximum height, your final velocity will be 0. Okay, then after V we have A. Okay, because this motion is in vertical direction, right? Therefore the force of gravity will be acting, and that's why acceleration of free fall also acts on it. Okay, what is the acceleration? That is G. But our direction is positive, upward direction is positive, whereas the force of gravity acts downwards. Okay, so this value will be minus G, and the value of minus G will be minus 10 meters per second square. So acceleration due to gravity is going to be minus 10 meters per second square. All right, so we have the required data. So we need to find an equation that has these four variables. So that equation is v square equals u square plus 2as. Okay, now so we need to find s. So let me first rearrange the equation. S becomes s max, v square is 0, u square is 45 whole square upon 2a. So that will be 2 times minus 10. Okay, so this becomes minus 900 divided by minus 20. The zeros cancel, the negative signs cancel, and therefore you will be left with 45 meters. Oh, sorry, my bad. 45 square, not 45 times 2. Sorry about that. So this basically becomes minus 2025 divided by minus 20. Okay, so the zeros cancel, and 2025 divided by 20, that will give us 101.25 meters. So that's your greatest height that the ball reaches. Okay. Now part B, it says find the length of time for which the ball is at least 25 meters above the point of release. Okay, now you need to understand from the wordings that is it asking about the time, that what is the time or how much time has passed when something happens, or is it asking about the duration? When it says find the length of time, that means he's talking about the duration, that for how long was the ball was the ball above 25 meters from the point of release. Okay, so let me draw the diagram so that it becomes clear. Let me copy this diagram now. Okay, so basically what the question is telling you is that if let's say that somewhere around here, let me let me just push it over here so that I have enough space. All right, let's say that I draw a line. This is the point, okay, which is 25 meters. Okay, 25 meters from the point of release. And S max, we just found out that this is 101.25 meters. The maximum height is 101.25 meters, and above 25 meters, that would be this much distance. Okay, so you need to find out that what is the duration then the ball was in this region. So when the ball is above this point, it goes all the way up. Okay, then it stops here, then comes back down. How much time has the ball remained above 25 meters? That is what the question is. Okay, very important. It is very important to understand the question first. All right. So what is the time when displacement is 25 meters? Okay, that means that if I apply the SUVAT equations, so S will be 25 meters. The displacement is going to be 25 meters. Okay, U will be 45 meters per second. Okay, that was a speed of projection. Then we don't really need that. In fact, we don't even have the value for that. A is minus G, okay, which is minus 10 meters per second squared. And we need to find time. So again, we can use the equation S is equal to UT plus half AT squared. The displacement is 25, U is 45 times T plus half into minus 10 T square. So this becomes 25 equals 45T minus 5T square. So this is a quadratic equation. Let me rearrange this equation first. 5T square minus 45T plus 25 equals to 0. We can see that all of these are multiples of 5, so we can divide the whole equation by 5, and we would get t square minus 9t plus 5 equals to 0. So now we need to factorize this. So that will be t square minus, so we need to find two factors that would multiply to give me 5, and when I add them, that would give us 9. Okay, so we cannot factorize this. So therefore, we'll be using the quadratic equation. Okay, so t is equal to minus 9 plus minus 9 whole square minus 4ac. Then we have under root over here, and that will be 2 times 1. From this, we are going to have two equations, 9 plus, and let me just work out what this part of the under root is. So we have 9 square minus 4 times 5. So that will be root 61 over 2, and the second value will be 9 minus root 61 upon 2. Okay, so 9 plus root 61 upon 2, that will give us 8.41 seconds, and when I work out the other value, that will be 0.595 seconds. Okay. Now, what do these values actually tell you, and why do we have two values? Because we need to find the duration, right? So if you look over here, when the ball was thrown upwards at time t is equal to 0.595, at this particular point, the displacement was 25 meters. Okay, then the ball went all the way up. Okay, it stopped over here, then it came back down. Again, when it reached the second point, what was the time at that particular instance when the displacement was 25? that was 8.41 seconds. So what is the duration for which the ball was above 25 meters? That will be the difference of these two values. Duration for which the ball was above 25 meters equals 8.41 minus 0.595, and when I work this out I would get 7.82 seconds. Okay, so this is the duration for which the ball was above 25 meters. That is the end of question number 2. So now let's move to question number 3. Now, those two questions were exam style questions. This is a past paper question which has been taken from June 2013, paper 41, question number 3. All right, so let's get started. The top of a cliff is 40 meters above the level of the sea. Okay. A man in a boat close to the bottom of the cliff is in difficulty and fires a distress signal vertically upwards from sea level. Find the speed of projection of the signal given that it reaches a height of 5 meters above the top of the cliff. Okay, so first of all, we'll make a diagram. Okay, so let's say that this is your sea level. Okay, and let's say that this is a cliff whose height is 40 meters. Okay, then it says that a man in a boat close to the bottom of the cliff. So the bottom of the cliff will be somewhere here, right? So let's say this is your boat and this is the man who is standing on the boat. Okay, then it says that he fires a distress signal vertically upwards from sea level. The speed of projection of the signal, find the speed of projection. Okay, so basically you need to find the initial velocity. Okay, so that is the question. Given that it reaches a height of 5 meters above the top of the cliff. Okay, so that means that it reaches this part. Okay, and the distance between where it reached from the top of the cliff, that is 5 meters. So we can say that the total height that the distress signal has traveled would be 45 meters. Okay, all right, so yeah, I think that's pretty much about it that we can draw on the diagram. So now we need to find out what is the speed of projection. Okay, so first let us write the data that is given to us. S will be 45 meters and I'm going to consider upwards as my positive direction. U is what we need to find. Okay, v okay, v will be 0 again. Why? Because it reaches the top, right? So that means that's the maximum height that it has reached. So therefore the velocity will be, final velocity will be 0, and we know acceleration, that is minus g, which is minus 10 meters per second square. So here we can use the equation v square equals u squared plus 2as. First we will make u square as a subject. So that will be v square minus 2as, and u will be under root v square minus 2as. So now we can just plug in the values. This will be 0 minus 2 times minus 10 times 45, and then taking square root. So u is equal to, all right, so u will be 30 meters per second. All right, so that was part A, or rather part 1 actually. Okay. Part 2, the length, find the length of time. Again, the length of time means duration, for which the signal is above the level of the top of the cliff. So you need to find the duration when the distress signal was above the top of the cliff. So that means it is above 40 meters. That means the displacement is going to be 40, because the distress signal, just like the ball in the previous example, it will go up, okay, it stops momentarily, then comes back down. Okay, so we need to find that what is this duration for which it has been above the cliff. So in second part, the displacement is going to be 40 meters. U will be 30 meters per second that we just found. Okay, then now here, because here we are not finding that about the final velocity, right? Final velocity, we don't know that at displacement of 40 what is the velocity, so we can cancel this one. A is minus g. Okay, and we need to find t. So s is equal to ut plus half at squared. S is 40, u will be 30t plus half into minus 10 t squared. 40 equals 30t. This becomes minus 5t squared. Again, I'm going to rearrange them. So 5t squared minus 30t plus 40 equals to 0. All of these are multiples of 5, so we can simplify the equation. So this becomes t squared minus 6t plus 8 equals to 0. So we need to find two factors. When we multiply them, that should give us 8. And when I add or subtract them, I should get minus 6. So that will be t squared minus 4t minus 2t plus 8 equals to 0. T will be factorized. Over here, minus 2 will be factorized. So t minus 4 times t minus 2. Therefore, t is equal to 4 seconds and t is equal to 2 seconds. Okay. Now, if I go back on the diagram, so this is the top of the cliff. Okay, that means that when it was traveling upwards, okay, when it is going upwards, at that time t was 2 seconds, and when it went back all the when it went up all the way, then it came back down. At this particular instance, t was 4 seconds. So therefore the duration for which it was above the cliff was 4 minus 2, which is equal to 2 seconds. Therefore duration equals 4 minus 2 equals 2 seconds. Okay, so we can write this over here. Just before I write this down, we can say that the signal was at 40 meters when going up at t equals to 2 seconds, and when coming down at t equals to 4 seconds. Okay, so this will add clarity if you didn't understand in the first place. All right, the last part of this question. Okay, it says the man fires another distress signal vertically upwards from sea level. This signal is above the level of the cliff for root 17 seconds. This signal is above the level of the cliff for root 17 seconds. That means that this is not the time, this is the duration. Okay, this is for how much time the signal was above the level of the cliff. Okay, Find the speed of projection of the second signal. So now you need to find out that what is the initial velocity of the signal. Okay. All right. So first, let us write down what do we know. We know that uh, sorry, we know that a is equal to minus 10 meters per second square. We know that t, which is the duration, okay, that would be root 17 seconds. Okay. And it says that uh, the signal this signal is above the level of the cliff for root 17 seconds. So what we can say here is that root 17, okay, this is the time for going up at maximum height from the top of the cliff. Okay. And then also coming back, and then back to the top of the cliff. Okay, this is a little bit tricky, so let me copy down this diagram. So that'll be a bit easier to explain. Okay, now we don't know exactly that what was the maximum height. Okay, so still we know that the height of the cliff is 40 meters. Okay, above 40 meters, let's say that the second distress signal, okay, it reached here, but we don't know what is this displacement. So let's just say that this is S. Then what we do know is that the duration is root 17 seconds. So the signal goes from here to the maximum point, comes back down. So again, in this region, that is the duration. If I try to work out that, we know that this root 17 is the time it goes to the maximum height and then comes back down. So what would be the time for halfway, the only reaching this part? That would be half of this time, right? So we can say that time is equal to root 17 upon 2 seconds for one way. Okay. All right. Now, first of all, we need to find out what is this S. Okay. Before we can find out U, we need to find out what is S. Okay. What's given to us? We know the acceleration, we know time, and because now we have deduced that this will be the maximum height, at this particular point, the final velocity is going to be 0. So let me write down the data again. S will be, S is what we need to find, right? So U, we don't know about that. We know that A is minus 10 meters per second square. We know that T is going to be root 17 upon 2. Okay, and we know that V is equal to 0 meters per second. Okay, because we are talking about the maximum height. Okay, so what is the displacement? So this value of S will give us this the height above the top of the cliff. So now over here you have to use an equation that is not given in MF19. Okay, that equation is S is equal to VT minus half AT squared. Okay, what you have been given is about the initial velocity. Okay, so this is very similar to this equation, except that instead of initial velocity you have final velocity, and instead of plus sign you have a negative sign. Okay, so because V is 0, this term becomes 0. You have half times minus 10 and this will be root 17 upon 2 whole square. Okay, so this will be 21.25 meters. So now I know that this S is 21.25 meters. Okay, now I know that what is the maximum height. I know the total displacement. If I start from the bottom all the way till the max height, I know what is the total displacement. Now I can find out the initial velocity. Okay, so what we can do is we can use the equation v square equals u square plus 2as. Okay, now v square, that is 0, u square, that is unknown, acceleration is minus 10. Now displacement is going to be this 40 plus 21.25. So u square will be equal to, all right, let me first calculate what this value is. 0 is equal to u square. Okay, and that will be minus 20 times 40 plus 21.25. So that will be minus 1225. So over here we can write u square is equal to 1225. So u is equal to square root of 1225. So when I take the square root of this, so I'm going to get exactly 35 meters per second. So this is the speed of projection of the second distress signal. All right, so the last one was a little bit tricky. Okay, so it's better that after understanding, okay, try to attempt the question by yourself, so it will give you a good idea of how the questions usually come related to these chapters. Okay, so all right, so we'll be ending this video. There are two more questions left. Okay, these two questions will be covered in the next video, so stay tuned. Take care. Assalamu alaikum.